Good morning, girls. Welcome to our essay revision session. In the previous class, we revised few important concepts of Unit 1, and now let us begin with Unit 2 concepts. And in Unit 2, from Part 1, let us revise requirement analysis and specification, and from Part 2, software design. Okay, so from requirement analysis and specification, let us revise introduction, requirements and gathering and analysis, requirement specification, SRS document, decision table, decision tree. Okay, now let us start with the introduction. So in this introductory part, first let us know why we should give much importance to requirement analysis and specification. Let us consider a software team is working for a project and they had not done any kind of requirement analysis and specification. Simply they gathered the requirements from the customer and started developing the software product. But they are not determining whether they are building that product according to the customer requirement or not. So finally, one day they complete that product. They give us a software product and there may not be any failures in that product. It may work properly, but obviously it is a failure project. Why? Because even though that product is working properly, if it is not according to the customer requirement, then obviously our project is failed. That means always the project fails if at all the software developers are not determining whether they are building what the customer really wants. First they should know what the customer really requires. Okay, so for that purpose it is very important to learn requirement analysis and specification techniques carefully. Okay, now coming to the major goals of this activity, that is requirement analysis and specification. So generally the major goals of this activity are, first thing is we should fully understand the user requirements and then try to remove the inconsistencies, anomalies from the requirements, and finally document the requirements properly in the form of a document called SRS document. SRS stands for Software Requirement Specification. So these are the major goals of requirement analysis and specification. What is the first goal? First we need to try to properly understand what are the requirements of the customer, then try to remove the inconsistencies, anomalies and any contradictions from the requirements, and finally whatever the requirements you had understood and from whatever the requirements you had removed these inconsistencies and anomalies, so you document those requirements in the form of a document called SRS document. So these are the three major steps that are performed during this requirement analysis and specification. So these three activities, in order to meet these three goals, the requirement analysis and specification is classified into two different activities. One is requirements gathering and analysis and the other one is requirement specification. So coming to the first activity, that is requirements gathering and analysis. This requirement gathering and analysis is also popularly known as requirement elicitation. Requirements elicitation. And the primary objective of this activity is to collect the requirements from the stakeholders or from various customers. Okay, so during requirements gathering, we are collecting the requirements from various stakeholders or from the customers. Then we perform analysis on those requirements. That means we try to understand whatever the requirements we had gathered from various customers, and we try to identify whether there are any incompleteness among the requirements, or whether there is any inconsistency among the requirements, or whether there is any ambiguity or anomaly in the requirement. If at all we come across these three aspects, that is incompleteness, inconsistency and anomaly, then we need to remove these three things from the gathered requirements. And in order to remove these ambiguity, incompleteness and inconsistency, obviously we meet the customer again. Okay, so in this manner we try to analyze the requirements and then remove any ambiguities, incompleteness, inconsistencies from that requirements. So now we are done with the requirements gathering and analysis. So once we properly understood this gathered requirements, then we go to the second activity, that is requirements specification. So during requirement specification, we document the gathered requirements, and that document is known as SRS document, that is software requirements document, software requirement specification document. Okay. Now, so before we go in depth with the activities, with these activities, first let us see who will carry these requirement analysis and specification. So generally this requirement analysis and specification is usually carried out by a few experienced members of the development team, and it is normally requires them to spend some time at the customer side. Why we are referring only experienced members of the development team means, if a new user goes to the customer and tries to gather the requirements from the customer, what he generally does is, whatever the customer says, he simply note it down and come back to the project area and started working over that. Since he is not having any experience with the previous projects, he may not be aware of what kind of issues that may arise while analyzing these requirements. Okay, so for that reason, it is always important, or it is always good to send experienced members in order to gather the requirements from the customers. Now, these engineers who gather and analyze customer requirements and then write the requirement specification document are known as system analysts. That means the person who is gathering the requirements and analyzing them and documenting them can be called as system analyst. An analyst analyzes collected data to understand what exactly needs to be done and writes SRS report. Next, the final output of this requirement analysis and specification is nothing but the SRS document, which is documented by the system analyst. So once the SRS document is ready, then what we do means, we give it to the customer for review. That is, whatever the SRS document that is prepared by the system analyst is given to the customer for reviewing. Now the SRS document is reviewed by the customer, that is, he goes through all his requirements, and if at all he feels any of the requirement is missing, or if at all he would like to change any requirement, or if at all he feels like any requirement is not necessary, then he informs the same to the system analyst. Now what the system analyst will do, he again modify the SRS document as per the customer suggestions, and then again he submit it to the customer for reviewing. So this is done until the customer accepts that SRS document. So that means until the review of the customer is successful, this system analyst performs the modification in the SRS document. So finally, this reviewed SRS document will form the basis for all future development activities. Why? Because it is accepted by the customer. So using this document, we can further go with the rest of the activities like designing, coding, testing, and finally deploying to the customer. Okay. Now, we can completely divide the requirements gathering and analysis activity into two separate tasks, that is the requirements gathering and analysis. So what we are doing during requirements gathering, so simply the system analyst will collect the various requirements from the customers or from the stakeholders. Okay. Now, what are the different ways of collecting the requirements from the customers? That means how to gather the requirements. Okay, so generally this gathering of requirements is classified into 5 different activities. That means we can gather various requirements from the customers by studying the existing documentation, by interviews, by task analysis, by scenario analysis, and form analysis. So coming to the first one, that is studying the existing documentation. So here the analyst usually studies all the available documents regarding the system to be developed before visiting the customer site. So all the available documents, in the sense, previously you might have worked on that project, or you might have or that particular company had developed a similar product. Okay, so whatever the available documents are there with us, we can revise those documents. So that means by studying the existing documents, we get some clear idea of what the customer requires. Okay, so we will be studying the existing documents before we go to the customer side. Next one is interview. So this activity is performed among various categories of users. So that means in order to perform interview, first thing you need to do is, first you need to identify who are the different categories of users of that software. So a software product may be used by different persons or different users, and you may have different categories of users. Okay, so first thing is you need to identify different categories of users of software. Next, for each category of users typically requires different set of features from the software. For example, if you consider any mobile phone, so one person may be using that mobile phone for gaming, one person may be using that mobile phone only for internet, and one person will use that mobile phone only for making calls and messaging. So that means here we got three different types of users. So first thing, we need to identify these three different types of users. Then we should identify what are the different features they are in need. So here in our example, we had identified three different categories of users. So obviously these three different categories of users may need of different features. So therefore it is important for the analyst to first identify different categories of users and then determine the requirements for each. To systemize this method, that is to collect the requirements from these different categories of users, we can follow a Delphi technique. Okay, according to that technique, the analyst consolidates the requirements as understood by him in a document and circulates it for the comments of various categories of users. So that means first we identified various various categories of customers, and from that various categories of customers, we gathered the requirements and then we documented the same. Now what this system analyst will do means, whatever the document he had done, that he will circulate to all the categories of users. Now these users will go through that document and they provide us the feedback. So based on that feedback, the system analyst will refine his document. So this procedure is repeated till the end users agree on the set of requirements. So that means we are trying to satisfy all the three categories of users in our example. Next category is task analysis. So before we begin with this task analysis, first you should know what do you mean by a task. Generally, whenever any user is using a software, he simply feels that that software is providing a set of services or functionalities. Okay, and that service is also called as a task. So that means for a user, a software is nothing but it is providing some service or it is doing some task. So now what we can do means, the system analyst should try to identify and understand different tasks to be performed by the software. So in task analysis, the system analyst first tries to identify and understand different tasks to be performed by the software. Next, for each identified task, the system analyst tries to formulate different steps to understand the requirement functionality in consultation with the users. So whatever the task he has identified, now he tries to formulate different steps to understand the required functionality by consulting the users. For example, let us consider we are having a service like issue book service, that is in a library management system. We are having one service like issue book. So in order to issue the book, we may come across different steps like authenticate user, check the number of books issued to the customer, and determine if the maximum number of books that the member can borrow has been reached, and check whether the book has been reserved, post the book issue details in the member's record, finally print out a book issue slip. Okay, so in order to perform a simple task, that is issue book, so these different steps are performed. Now what the system analyst will do, first the system analyst has identified this issue book. Okay, after identifying this issue book service, so in order to issue a book, what are the steps that are required? So now in the next step, he is identifying these steps in order to perform that issue book service task. Okay, so this is task analysis. So during task analysis, first the system analyst will identify the task, and then he try to identify what are the different steps in order to perform the task. And in order to identify different steps, he is consulting the user. Okay, so that is task analysis. Next one is scenario analysis. A scenario analysis means a task can have many scenarios of operations. The different scenarios of a task may take place when the task is involved under different situations. That means whenever you are performing a task, it may result in different kinds of output, and that different kinds of output can be considered as a scenario. For example, if at all you are performing a issue book task, so the book may be here the different scenarios, that is the different outcomes of this task can be: the book is issued successfully, or the book is reserved and hence cannot be issued to the member, or the maximum number of books that has been issued to the member is already reached and no more books can be issued to the member. So that means scenarios are nothing but whenever a task is performed, what are the different kinds of outputs that we may get. Okay, so those are nothing but the scenarios. Okay, so once we had completed with the task analysis, then it's necessary to perform this scenario analysis. Okay, so after performing scenario analysis, then you can go with the form analysis. So this form analysis is generally done whenever you are having some existing system, that is let us consider the library management system is now done manually and now we are trying to automate it. So since we are trying to automate an existing system, so whatever the documents or whatever the forms that are there in the existing system, we try to understand those documents, that is those forms, and try to identify what would be the requirements for the system that we are automating it. Okay, that's nothing but the form analysis. So it is an important and effective requirements gathering activity that is undertaken by the analyst. So when the project involves automating an existing manual system. Okay, so that is the form analysis. So in studying the existing documentation, just the system analyst will study the existing documents of the previous projects. During interviews, he conduct interviews. We can conduct interviews with the various categories of customers and gather the requirements. During task analysis, the system analyst will identify what are the various tasks and what are the steps that are required in order to perform that task. And in scenario analysis, for each identified task, it may result in different kinds of outcome. That is nothing but a scenario. So here the system analyst will try to analyze what kind of scenarios that may occur for the given task. And finally, in the last activity, that is form analysis. So this form analysis activity can be accomplished whenever we are having an existing system, that is existing manual system. So from the existing manual system, whatever the forms or whatever the available documents are there, just by analyzing those documents or those forms, we go for the gathering the requirements for the new system. Okay, so this is how we gather the requirements. Okay, now suppose if at all we are not having any existing system, that is in the absence of a working system, then how the requirements should be gathered means it's completely a lot of imagination and creativity are required. Why? Because we don't have anything in hand now. We are trying to work on a new project which has not been developed by anyone so far. It is completely different when compared to the previous existing projects. So in that case, we need a lot of imagination and creativity, and this lot of imagination and creativity can be improved if at all we are having a lot of experience. Okay, so an experienced system analyst can have a lot of imagination and creativity. Now coming to the attributes of a good system analyst, that means who can be a good system analyst. So in order to be a good system analyst, that system analyst should have good interaction skills. Why? Because he need to communicate with various categories of customers. Next, he should have imagination and creativity. So this second attribute is required whenever there is no working model. And next is experience. So his previous experience will help him to gather and analyze requirements within a short period of time. Okay, so these three are the attributes of any good system analyst. So let us consider a case study. So where we are in this case study, we are trying to automate an office work at CSC department. Okay, so here we are having an existing system, that is which is done in a manual manner, and now we are trying to automate it. Okay, so let us see what is the existing system. So the academy, inventory and the financial information at the CSA department being carried through manual processing by 2 office clerks, a storekeeper and 2 attendants. Okay, so we are having an manual system where we are storing all the CSC department related information, that is academic, inventory, financial information, and this information is always carried or is always processed by 2 office clerks, storekeeper and 2 attendants. Okay, now the HOD entrusted the work to a team of student volunteers. So now what the department, that is head of the department of CSC, had asked few student volunteers to automate this system. That is, he is asking to develop a software product in order to automate the existing manual system. Okay, now the team was first briefed by HOD about specific activities to be automated. So first, HOD has assigned some work to the students, and at the same time he will briefly explain what kind of activities that automation system has to perform. With that brief explanation of HOD, these students will not be able to develop the software product. Why? Because it's just a brief explanation of the requirements. Okay, so in order to have a good analysis of all the requirements of that new software product, first they need to meet the persons who are using the manual processing. That is, they meet now those 2 office clerks, storekeeper and attendants. Okay, now these student volunteers will interact with those people and will try to understand what are the daily activities that are taking place, that is what kind of tasks that are taking place in that manual processing system. And they also interview some student and faculty representatives who would also use the software. So since finally this software may be used by the students and faculty people also, so they interact with the student and faculty representatives, and finally they finish with the requirements gathering. Okay, so now in this case study, the students has gathered the requirements from HOD, from the people who are processing the manual system, and from the student and faculty representatives. So that means they had completed with requirements gathering. Next, for each task, they asked about the steps through which these are performed. They also discussed various scenarios that might arise for each task. The analyst collected all types of forms that were being used. Okay, now they are trying to analyze the gathered requirements. So about they ask about the steps through which these are performed. If at all they had identified any task, okay, they ask about the steps in order to accomplish the task. To whom they will ask? So if at all that task is performed by the clerk, then they meet the clerk and they ask him what are the steps to accomplish this task. Okay, next, they also discuss various scenarios that might arise for each task. And finally, the analyst collects all types of forms, that is the form analysis is done. Okay, so in this manner we had gathered the requirements. Okay, so once the requirements gathering is done, then we go for the analysis of gathered requirements. The main purpose of requirements analysis is to clearly understand the user requirements, and if you find any inconsistencies, ambiguities and incompleteness, try to remove those from the requirements. Okay, so we can remove these inconsistencies, ambiguities and incompleteness from the requirements by consulting the end users or the customers. Now let us see what are these incompleteness, ambiguity and inconsistencies. Now coming to the ambiguity. Ambiguity is also called as anomaly. So anomaly in the sense, whenever a requirement leads to the several interpretations, then that requirement is considered as anomalous requirement or ambiguity requirement. That means just by seeing one requirement, if we are able to make more than one interpretation out of it, then it's nothing but an ambiguity or anomalous requirement. For example, if you consider when the temperature becomes high, the heater should be switched off. Okay, so here the requirement is given by the customer that when the temperature becomes high, the heater should be switched off. So I may think high means it may be 100 degrees Celsius, but according to the customer, he feels high means some 200 degrees Celsius. Now what happened? The interpretation which is done by me is wrong. Okay, and what I will do, according to my interpretation itself, I will try to prepare the software product. So ultimately, whenever the product is delivered to the customer, obviously he rejects it. Why? Because it is not according to the customer requirement. So here the word high are led to the various interpretations. That means these kind of words leads to the ambiguity among the requirements. See here, an anomaly in any requirement can lead to the development of an incorrect system. So obviously what I had thought high means 100 degrees Celsius, but according to the customer high means 200 degrees Celsius. Okay, so we may get different kinds of interpretations which leads to the incorrect nature of the software product. Okay, so some of the words which lead to the anomalies or ambiguities among the requirements are high, low, high, low, good, bad, etc. Okay, so these are the, so whenever you find any these kind of words in the requirements, then obviously you can feel that it is an ambiguous requirement. Go to the customer and clarify the this ambiguity in that requirement. Next one is inconsistent requirement. Two requirements are said to be inconsistent if one of the requirements contradicts the other. So that means the customer had given a two requirements, and those two requirements are quite opposite to each other. Then we can say there is an inconsistency among the requirements. For example, let us consider requirement 1 as the furnace should be switched off when the temperature of the furnace rises above 500 degrees Celsius. That means when the temperature becomes 500 degrees Celsius, you need to switch off the furnace. But coming to the second requirement, when the temperature of the furnace rises above 500 degrees Celsius, the water shower should be switched on and furnace should remain on. If you see in requirement 1, if the temperature rises above 500 degrees Celsius, the furnace should be switched off. The furnace should be switched off. But in second requirement, what is happening? The furnace should be remain on itself. So here there is a contradictory among these two requirements. It's nothing but an inconsistency. So again what we can do, again go to the customer and ask him whether to keep the first requirement or the second requirement. So based on his suggestion, we can modify the same in the SRS document. Next one is incomplete requirement. So sometimes requirements have been omitted, possibly due to oversight. So that means a requirement is provided. We had gathered some requirement, but in future we may not identify whether that requirement has been provided with complete information or not. For example, let us consider a customer has given you a requirement that if a student is absent, then send message to his or her parents' phone number. Okay, so this is the requirement given by the customer. But on examination of all requirements, that is whenever you are trying to analyze the requirements, it was found that there is no provision by which the phone numbers of the students' parents can be entered into the system. That means none of the requirement is dealing with the parents' phone number. Okay, so here this is an incomplete requirement. Okay, so here you are asked to send a message to the parent number when the student is absent, but in none of the requirement there is no specification of collecting parents phone numbers or updating the parents phone numbers in any database. Okay, so this is an incomplete requirement, and this is because of possibly due to oversight. Okay, next, this requirement analysis involves obtaining a clear, in-depth understanding of the product to be developed, to remove all ambiguities and inconsistencies from the initial customer perception of the problem. So, in order to remove all these ambiguities and inconsistencies, one should have a clear idea and in-depth understanding of the product that is to be developed. But it is quite difficult to obtain a clear, in-depth understanding of the problem, especially if there is no working model of the problem. Experienced analyst takes considerable time to understand the exact requirements the customer has in mind. If at all he is a new analyst, that is a novice analyst, will take more time to understand what are the exact requirements that a customer has in his mind. But because he had not worked for any projects. Okay, if he is a experienced analyst, then before the customer clearly explains about his requirement, the analyst can identify what he is going to say. He can analyze what he is going to talk about his requirement. Okay, so that's what the advantage of having experienced analysts in the software development team. Several things about project should be clearly understood by the analyst. What is the problem? Why is it important to solve the problem? What are the possible solutions to the problem? What complexities may arise while solving the problem? If there are external software or hardware which the developed software has to interface, then what should be the data interchange formats with the external systems? So before documenting the SRS report, that is before the system analyst goes for requirement specification, first he should get the answers to all these questions. What is the problem? That means in order to have a clear and in-depth understanding of the problem which is to be developed, first he need to get the answers for all these questions. So these are the commonly raised questions among the system analysts whenever they are trying to work for any project, that is whenever they are trying to analyze the requirements. So once the answer for all these questions are obtained by the system analyst, then it's nothing but we can say he got a clear understanding and in-depth understanding of the product that is going to be developed. Okay. After the system analyst has understood the exact customer requirements, he proceeds to identify and resolve the various problems that he detects in the gathered requirements. Okay. So once he had completely analyzed what are the requirements of various customers, then he goes to the next activity, that's nothing but requirement specification. So during requirement specification, what this system analyst will do, he will systematically organize the requirements arrived during requirements analysis and document requirements properly. So whatever the requirements he had gathered and whatever the clear understanding he made, that is whatever the analysis he made, so based on his analysis, now he tried to organize all the requirements in a systematic manner so that the document can be easily understood by anyone. So that document may be referred by the customer, it may be referred by the development team, and sometimes even the managers may go through those documents. So it's always necessary to arrange all the requirements in a systematic manner. Okay. And coming to the importance of this SRS document, this SRS document is useful in various contexts. The first and important one is statement of user needs, contract document, reference document, definition of implementation. So statement of user needs, that's nothing but whatever the user requirements are there, that we had documented the same in the form of SRS document. Next one is contract document. That means SRS document is prepared by the system analyst. What are there in the SRS document? The requirements which had gathered from the customer. Now what we will do means, we give the SRS document to the customer for review purpose. Now the customer will review our SRS document and he provides the feedback. Feedback in the sense he may provide any modifications. Based on that modifications, again the system analyst perform the changes in the SRS document and produce the same to the customer for reviewing. So this process is continued until the customer accepts. Okay. So that means we can consider this as a contract document. Later, the customer should not say whatever the product we had developed is not according to his requirement. That means in order to solve any legal issues, we can use this SRS document as a contract document. Why? Because it is accepted by the customer. Okay. Next, reference document. Reference document in the sense, we using this document itself, we start designing. Okay, using the same document, we can go with the coding part. Okay, so in further software development activities, this SRS document is used as a reference document. And in the same way, definition, it acts like a definition for implementation. So during the coding part also, that is during implementation stage also, we will be making use of this software requirement specification document. Okay. So what I had already said you is that contract document. So this is the major important context of SRS specification document. So requirements document is a reference document. It acts like a contract between the development team and the customer. So once the SRS document is approved by the customer, any subsequent controversies are settled by referring the SRS document. So any legal issues that any legal issues are raised after developing the product and deploying the product to the customer, those legal issues can be resolved by using this SRS document. So we can say this SRS document is acting like a contract document between the development team and the customer. Why spend time and resource to develop an SRS document? Why we require to spend much amount of time, much resources in order to develop an SRS document? So what would be the reason? So these are the reasons for spending more amount of time on SRS, on preparation of SRS document. The first one is it forms like an agreement between the customers and developers. So this is the main reason why we should spend much time, why we should spend much resources in developing the SRS document. Okay, it is acting why? Because it is acting like it forms like an agreement between the customers and developers. Next, it reduces future reworks. Why? Because the customer has accepted those SRS document. No further modifications can be done. So we can fix those requirements and we can proceed with next activities during software development. So no need to perform any modifications during design. No need to perform any modifications during coding. Okay. So it's nothing but it simply reduces the future rework. And it provides a basis for estimating costs and schedules. So in the second phase, that is in the planning phase, we go for estimation of cost and scheduling, that is tracking. Okay, so in order to estimate the budget and schedule of the software development life cycle, we can make use of this SRS report. And it also provides a baseline for validation and verification. Yes, whenever you are developing any product, validation and verification are very important. Why? Because this will check whether we are developing the product as per the customer requirement or not. So if at all we don't know what the customer actually needs, can we go for validation? Can we go for verification activity? Obviously no. Just we will be referring the SRS document and we check whether everything is going on as per the SRS document or not. For example, you are in a coding activity. That means you are writing some lines of code. Okay. Now we can verify whether whatever the code we are writing is according to the customer requirement or not. Okay. So in that manner, this SRS report is acting like a baseline for validation and verification. And the last one is it facilitates future extensions. So that means by using the SRS document, we can go for further enhancements. That is, we can add any new features for the so far developed product. Okay, so these are the main reasons why we should spend most of the time for developing the SRS document. It's a forms. Let us revise again these reasons. It forms as an agreement between the customers and the developers. It is reducing the future rework. It provides a basis for estimating the cost and schedules. It provides a baseline for validation and verification. And it is facilitating future extensions. Okay. Now coming to the properties of good SRS document. So simply by preparing an SRS document is not enough. It should have certain characteristics or certain attributes or properties in order to call it as a good SRS document. So when an SRS document can be a good SRS document means, first it should have concise. That means it should be concise and at the same time unambiguous, consistent and complete. So that means it has to discuss about the requirement in short. No lengthier explanation of that requirement is necessary. Okay, so within a fewer words we need to able to explain the requirement of the customer, and that requirement should not have any ambiguity, it should not have any inconsistency, and it should not be incomplete. That means a concise requirement should have unambiguity, consistent and complete nature. Okay. Next, it should specify what the system must do and not say how to do it. So it has to simply represent this is the requirement of the customer. It should not say how that requirement has to be fulfilled. Okay, that means the SRS report should be implementation independent. We should not discuss any implementation details in SRS document. Next one is it should be easy to change. That means it should be well structured. A well structured document is easy to understand and modify. Okay. So how we can have a well structured SRS document, that let us see in the next upcoming slide. Okay. Next, it should be traceable. That means you should be able to trace which part of specification corresponds to which part of design or code and vice versa. So that means if at all you are trying to identify whether the requirement is fulfilled in the coding part, you should be able to identify it. You should be able to identify the corresponding requirement in the coding. And at the same time, you should be able to identify a function in the code with the requirement specified in the SRS report. So that kind of traceability should be there in the SRS document. And it should be verifiable. That means it should be possible to design test cases based on the description of the functionality to check whether or not requirements have been met in an implementation. So generally we write test cases after completion of coding. So once we are done with the coding part, then we go to the testing. So during testing, we should write different test cases. So in order to write test cases, obviously we need to refer the SRS document. So the SRS document should be in a verifiable manner. That means the requirement should be understood by the testing people properly. Okay. So these are the good properties of the good SRS document. So the first one is concise, next one is implementation independent, next one is well structured, it should be traceable, and finally verifiable. Now coming to the properties of bad SRS document. Until now we had seen the properties of the good SRS document, and now the properties of bad SRS document. So if at all any SRS document is having these four attributes, that is over specification, forward references, wishful thinking, noise, then that kind of SRS document is a bad SRS document. Over specification in the sense like what is the requirement, only the detailed explanation of that requirement should be specified. No extra information has to be specified in that requirement. For example, let us consider a customer has given a requirement like the files should be verified by the accountant. The files should be verified by the accountant. So whenever you are writing the SRS report, you should write the requirement as the files should be verified by the accountant. For example, if at all you are writing like the files should be verified by the accountant and the timings of that accountant are 8 to 5. Okay, so there it's not necessary to discuss about the timings of that accountant. So that's nothing but the over specification. Okay, just give the relevant information in the SRS document. Next one is forward references. So you should not mention anything like in future this requirement may be modified in this manner. It is like a forward reference, that kind of forward references should not be given in the SRS report. Why? Because you need to talk about what you should develop for that project itself. No future enhancements should be mentioned in the SRS report. The SRS report will act like a future enhancement, but those future enhancements should not be mentioned in the SRS document. Next, wishful thinking. Wishful thinking in the sense, if this requirement is met, then we may have this nature. Okay, that kind of explanations, that kind of visual thinking should not be mentioned in the SRS document. Like if this software product is good, then ultimately it leads to appraisal from the various customers. Okay, that is a kind of visual thinking. Okay, so that kind of issues should not be mentioned. And finally, noise, generally noise is something which disturbs us. Okay, in the same way we can have a noise in SRS document. So that noise is nothing but that SRS document has to discuss only about the requirements of the customer. It should not provide any other irrelevant information in the SRS document. Here, the irrelevant information is considered as a noise in the SRS document. Okay, so if at all any document, any SRS document is having these four properties, then it is a bad SRS document. Even though your document is having these good properties like concise, implementation independent, well structured, traceable, verifiable. Okay, along with this, if at all it is having these natures also, these properties also, then obviously it will become a bad SRS document. Okay, now coming to the how to structure this SRS document. So I said you right, in the next upcoming slide we will see how we can form a well structured SRS document. Okay, so here we in the from these slides we can see that one. Okay, so before we start with the structuring of the SRS document, first let us know what are the different types of requirements a customer can have. Okay, so generally the customer requirements are categorized into three types: functional requirements, non-functional requirements, and goals of implementation. So coming to the functional requirements, these functional requirements are nothing but the major functionalities of the product that a user requires. So that means here if you consider any library automation system, issuing a book, it is a requirement. Okay, so this can be considered as a functional requirement. Why? Because it is one of the major requirement of the customer. Okay, so these functional requirements capture the functionalities required by the user from the system. It is desirably to consider every system performing a set of functions, and each function is considered as transforming a set of input data to corresponding output data. If at all any requirement of a customer is taking some input data and after performing some processing on that input data, if it is leading to some output data, then that can be considered as a functional requirement. Okay, so in simple term, you can suppose if you are going through any requirement, if you identify that requirement is taking some input and it has to produce some output, then simply you can consider it as a functional requirement. Okay, so for example, let us consider search book. In a library automation system, we can have one requirement like search book. So in order to perform this task or in order to fulfill this requirement, you need to give some input, that is you need to give some author's name. So what is the output you can get? That is the details of the author's book and the locations of all these books in the library. That means for this requirement you are providing some input and you are getting some output. So this requirement can be considered as a functional requirement. The functional requirement will always take some input, perform some processing on it, and produces some output. Okay, the functional requirements describe a set of high-level requirements. Each high-level requirements takes in some data from the user, outputs some data to the user. And each high-level requirement might consist of a set of identifiable functions. And these functions can be considered similar to the mathematical function, that is f of I tends to 0, meaning that the function transforms an element ii in the input domain I to the value oi in the output range o. Okay, so that means if so you just just observe two things to define the functional requirement. To identify whether it is a functional requirement or not, just identify two things. One thing is the function has to take some input and it has to produce some output. And another thing is, if at all you are able to write that function, that is write that requirement in the form of a mathematical function, then it's nothing but a functional requirement. Coming to the non-functional requirements. So here in the non-functional requirements, they doesn't have any input and output, and these non-functional requirements cannot be represented in the mathematical function. Okay, but these are non-negotiable obligations that must be supported by the software. Even though this is not taking any input and output, even though we are not able to represent it in the form of a mathematical function, these non-functional requirements should be met by the developers. Okay, so these are so such a kind of requirements can be considered as a non-functional requirements. The non-functional requirements capture those requirements of the customer that cannot be expressed as functions, that is accepting input data and producing output data. So some of the non-functional requirements may be like concerns related to external interfaces, user interfaces, maintainability, portability, usability, maximum number of concurrent users, timing, and throughput. So if you observe these requirements of the customer, are they taking any input? No. Are they producing any output? No. Are we able to represent these requirements in the form of a mathematical function? No. So all these requirements falls under non-functional requirements. Okay. Now coming to the categories of non-functional requirements. The different categories of non-functional requirements are design and implementation constraints, external interfaces required, and other non-functional requirements. Coming to the design and implementation constraints, if at all any non-functional requirements is talking about how the software has to be designed, like the product has to use a database, it should use a SQL database. Okay, and the software product should be developed by using any object oriented programming language like C++. So this is a design and implementation constraint. Why? Because I'm discussing about how that software has to be designed. What should be the implementation language for that software to be developed? Okay. So if you observe, does this requirement is taking any input? No. Is it giving any output? No. Rather, I had given some requirement regarding the design and implementation of the product. Next, external interfaces required. So if at all I had given one requirement like, so whatever the software that is going to be developed, it should interface with, like I may say, Google Pay or Phone Pay. Okay, so that means that software product should get connected to Google Pay or Phone Pay. Now, is this requirement taking any input? No. Is it giving any output? No. But it's giving some suggestion to the developer. Okay, so that kind of requirements falls under external interfaces. So the requirements which deals with any external interfaces that a product should have, those requirements falls under external interfaces required. And whatever the other non-functional requirements like maintainability, portability, usability, maximum number of concurrent users, performance, timing, throughput. Okay, so all these comes under other non-functional requirements. Okay, the non-functional requirements are categorized into three types: design and implementation. So these deals with the design and implementation constraints. Next one is to which the software product has to get interfaced, that is get connected, and other non-functional requirements like maintainability, portability, usability, performance. Okay, all this comes under other non-functional requirements. Next, coming to the last category of requirements, that is goals of implementation. So these goals of implementations are just suggestions regarding the software to be developed. The developers may consider these suggestions if possible, and It's not mandatory to follow these suggestions. Okay, just while developing the software product, just they keep in mind about these suggestions, and it's not mandatory to follow all these suggestions. Okay, and these suggestions will not be checked for compliance. That means the later we may not check whether that requirement is fulfilled or not. Okay, for example, if you consider the functional requirements, obviously we check at the end whether that functional requirement has been met or not. And if you see, if you fulfill any if the customer had given you any non-functional requirement, that is any goals and implementation constraints, external interfaces required, other non-functional requirements, so finally after the product has been developed, we need to check whether all these requirements have been satisfied or not. But coming to the goals of implementation, we will not check whether the goals of implementation requirement has been met or not. For example, reusability, the functionalities to be developed in future. Okay, so these do nothing with the product we are going to develop. Okay, it's not mandatory to follow these two suggestions. Okay, so such a kind of suggestions or the requirements falls under goals of implementation. These are just the suggestions which may not be considered, which are not mandatory, and which are not checked after the product is developed. So now let us revise the differences between these functional, non-functional and goals of implementation. And functional requirements, here the requirement will be having some input and it produces some output, and it will be we will be able to represent it in the form of a mathematical function. Okay, so the major requirements are nothing but the functional requirements, and the requirement which we are not able to represent in the form of a mathematical function, or which is not taking any input and producing any output, but it has to be met by the developer, but that requirement has to be compulsorily met by the developer in order to satisfy the customer, then that kind of requirements falls under non-functional requirement. And coming to the goals of implementation, if any of the requirement is considered just like a suggestion, and if it is not mandatory, and if it is not checked later, then that kind of requirement is nothing but goals of implementation. Now coming to the organization of SRS document. So if this is the organization given by IEEE standard 820. So according to IEEE 820, the SRS document, first it has to start with the introduction. Okay, so that means we will be discussing about in like aim of the project, what is the main objective of that project, and little bit we'll be providing some company related details. Next, overall description of organizing the SRS document. Sorry. Next, functional requirements of organizing the SRS document. Next, external interfaces required. Next, other non-functional requirements for organizing SRS document, and goals of implementation. Okay, so in this manner we organize the SRS document. Now let us see how to represent the functional requirements. Okay, so this is the format how to represent the functional requirement. Suppose let us consider we are having a requirement. Let us consider it as operation mode 1. And if that requirement can be further divided into two sub requirements, then give it like in this manner: A, functional requirement 1.1. Here why it is given as 1.1? Why? Because it is the sub requirement of requirement 1. Okay, so 1 dot functional requirement 1, and in functional requirement 1 we are having sub requirement, that is functional requirement 1.1. Next, another one, functional requirement 1.2, and then we can have some other requirement. So operation mode 2, that is the second requirement, and in the second requirement if at all we are having the sub requirements, then that can be represented as 2.1, 2.2. So let us see one example. So here the customer has given two requirements. Okay, list all the functional requirements with proper numbering. The first requirement is, once the user selects the search option, he is asked to enter the keywords. The system should output details of all books whose title or author name matches any of the keywords entered. Okay, this is the requirement given by the customer. So here you can find there is an input and there is an output. The input is nothing but entering the keyword. The output is nothing but, so it simply displays the details of all books whose title or author name matches with the given keyword. Okay, so that means this requirement falls under functional requirement. Okay, the second requirement is when the renew option is selected, the user is asked to enter his membership number and password. After password validation, the list of books borrowed by him are displayed. The user can renew any of the books by clicking on the corresponding renew book box. Obviously, yes, it is also a functional requirement. Why? Because it is taking the input and it is producing some output. Okay. So now that requirement 1 can be represented in this manner. So in the requirement 1, the first requirement is to enter the keyword in the search option, and the second one is to display the list of that is the details of books that which match with the given keyword. Okay, so that means we got here two sub requirements. So coming to the requirement 1.1. In the requirement 1.1, the input to that requirement is nothing but the search option, and the output is the user is just prompted to enter the keyword. Okay, so this is one sub requirement of first requirement. The second sub requirement is the input is nothing but the keyword. That is what in the previous requirement it has asked to enter the keyword, right? So now in the second requirement we are entering that keyword. That is the input is nothing but the keyword, and the output is the details of all books whose titles or author name matches any of the keywords. Okay, so it will display the details of all books. Details in the sense the title, author name, publisher name, year of publication, ISBN number, catalog number, location in the library. Okay, all these details of the matched books will be displayed as a output. And here some kind of processing is taking place. What is that processing? It is searching the book list for the keyword. So in the database you are having a book list, and from that book list it is searching for the matched keywords. Okay, that means some kind of processing is done here. Okay, so it's nothing but the functional requirement 2. Next, coming to the requirement 2. So in the requirement 2, first we can here this requirement 2 can be divided into 3 sub requirements. Why? Because first we need to select the renew option, then we need to enter the password, then we can select any book for renew. That means here we are giving 3 inputs. Okay, so we can divide this requirement into 3 sub requirements. Okay, so here the requirement numbering is 2. So its first requirement number should start with requirement 2.1. Okay, the input is renew option selected, and the output is user is prompted to enter his membership number and password. So in the second requirement, that is sub requirement of the second requirement, the input is we will be entering the membership number and the password, and the output is the list of books borrowed by a user are displayed. And next the user is prompted to enter the books for which he requires the renew, and user is informed about bad password. Suppose if he had not entered proper membership number or password, so it may give this output also. So that means here we got 2 scenarios. Okay, this is scenario 1, this is scenario 2 for the task. Okay, next, here what kind of processing is taking place in order to meet the second sub requirement? Password validation, search books issues to the user from borrower list, and display. Okay, so this is the processing that is taking place for second sub requirement. Now coming to the third sub requirement. So now here the user will enter the book which is to be renewed. Okay, so user choice for renewal of the books issued to him through mouse clicks in the corresponding renew box. That means he select the books which are to be renewed. Next, output the confirmation of the books renewed. processing, it renews the books selected by the borrower list. Okay, so in this manner we can represent the requirements. Okay, this is a this we can, with this, by seeing this we can say that all the requirements are well structured, right? We are organizing each and every requirement properly by using the numbering system. Okay, first a requirement is given, and that requirement is again further divided into sub requirements, and for each sub requirement we are also again giving the numbering, and we are also mentioning what is the input, what is the output, and if at all any processing is taking place, then that processing information also we are representing. Okay, so in this manner we can represent the functional requirements in an organized format. Okay, now coming to the representation of complex processing logic. Sometimes a high level function might involve different steps to be undertaken as a consequence of some decisions made after each step. So that means if at all like any condition is satisfied, again it has to perform some other task. If the condition is not satisfied, it has to perform other task. Okay, so such a kind of conditional based statements or such a kind of complex processing logical statements, we can't represent them properly. Even though we represent them in the form of a text, some people may feel it difficult to understand. Okay, so in order to overcome that, that is in order to represent such a kind of complex processing logical statements, we are provided with two optimal solutions. They are decision trees and decision tables. So coming to the decision tree, a decision tree gives a graphic view of logic involved in decision making and corresponding actions taken. Okay, so here in the decision trees, each edge of the decision tree represents a condition, and leaf nodes represents actions to be performed. So finally at the leaf nodes itself we will be able to identify what are the actions that are to be performed. There will be no intermediate nodes. Okay, so here the decision tree gives a graphic view of logic involved in decision making and corresponding actions taking place. So let us consider one example. So here we are seeing an example of library membership automation software. It has to support three options: new member, renewal, and cancel membership. Okay, so here the requirements are: when the new member option is selected, the software has to ask details about the member, like it has to ask the user to enter his name, address, phone number, etc. Okay, and if proper information is entered, the membership record for the member has to be created, and the bill is printed for the annual membership charge plus the security deposit payable. Okay, so whenever a new member option is selected by the user, it has to perform these tasks. Now whenever he selects renewal option, LMS, that is a library management system, should ask the member's name and his membership number. Okay, whenever the user selects renewal option, the system has to ask him to enter member's name and membership number. Then it should check whether it is a valid number or not. If the name represents a valid number, then the membership related details has to be displayed, and the same thing has to be updated, and annual membership bill is to be printed. Suppose if the membership if the member name or member name or membership number is not entered properly, or if he is not a valid member, then it has to display the error message. Finally, if he selects the cancel membership option, then is selected and name of the valid member is entered. Okay, if the cancel membership option is selected and name of the valid member is entered, the membership is cancelled, a check for balance amount due to the member is printed, and the membership record should be deleted. Okay, so while selecting these three options, their respective activities, their respective tasks has to be taken place. Okay, now if we mention these requirements just in the form of a text, it will be difficult for some users to understand. Okay, why? Because many ifs conditions are there. Okay, so it will be difficult to understand. Rather, we can go with the diagrammatical representation of these requirements. So here you can see we can have a valid section or invalid section. Okay, so first let us consider the customer has selected the proper option. Okay, yes, proper option, yes. Okay, suppose if the customer has selected new member, then these actions has to be taken place. That means it has to ask for member's name, address, and then it has to create membership record and then print the bill. If he selects renewal, then it has to perform these set of actions. And if he selects cancel membership, then it has to perform these set of actions. And finally here we are printing the non validation section also. If option is not properly selected, then it has to display the error message. Okay, if at all anything goes wrong, it has to display the error message. See here, if you observe here the edges of the notes, on the edges of the notes we are representing the conditions. Okay, and the leaf notes are representing the actions that takes place for each respective condition. Okay, now coming to the decision table. So generally we require decision table whenever we are having multi-conditional statements. That for example, if at all we are having if else statements, if else, if that kind of statements are there, then it will be difficult to represent in the form of a text, and at the same time it will be difficult for us to represent in the form of a decision tree also. Okay, so in order to overcome that, we will be making use of these decision tables. These decision tables specify which variables are to be tested and what actions are to be taken if the conditions are true, and the order in which decision making is performed. Okay, so here we can represent what kind of multiple situations that may arise just by using a tabular format. Okay, so here the decision table shows the decisions making logic and corresponding actions in the form of a table. And in this table, the upper rows of the table specify the variables or conditions to be evaluated. So that means in the upper rows of the table, we just represent the conditions, and in the lower rows, its respective actions are mentioned. So in technical terminology, here a column of a table is called as a rule. Why? Because if that rule, that is if that condition is true, then its corresponding action will takes place. If that condition is true, then a corresponding action takes place. So hence here the columns are termed as a rules. So let us see the same example. So here the upper row represents the conditional statements, and the lower rows represents the actions for those conditions. Okay, and in this decision table we are able to represent all conditions, that is all combinations of three conditions. Okay, so this conditional column is also called as conditional hub, and this is the action stub. Okay, now in condition stub we may have various conditions like valid section, new member, renewal, cancel. Okay, so if valid section is no, that means if the customer has not properly entered into the valid section, then what kind of action has to take place? It has to simply display the error message. Okay, so in that action entry, just we represent it by an into mark. It indicates that this action will takes place. If this condition is satisfied, then this action will take place. Okay, then let us see the next combination. The valid section is yes. If the valid section is yes, and if the new member is yes, that means if we had selected new member, obviously renewal and cancellation will be no. Then this set of actions will take place. It will ask to members it will ask to enter the member's name. Next, it will build the customer record and it generates the bill for the customer. So since it is a new member, okay. Next, it is a valid section, but it's not a new member, but it's a renewal option, okay. So obviously renewal option is yes means cancellation will be no. So renewal option is yes means what will be printed? It will ask the membership details, okay. Then it will update the expiry date and again it will generate the bill, okay. So these set of actions that take place whenever the renewal condition is yes, okay. Now coming to the last one. The valid section is yes, new member no, renewal no, but cancellation is yes, okay. So whenever a person wants to cancel his membership, what actions will take place? So it will ask to enter the member details, it will delete the record and it will print the check, that is whatever the balance amount that has to be refunded to the customer, that will be printed, that particular bill will be printed, okay. So in this manner we can represent the set of actions for the corresponding conditions, okay. Now let us see the comparison between this decision table and the decision tree. In both decision tables and decision tree, we can represent complex program logic, but decision trees are easier to read and understand when the number of conditions are small. If at all you are having less number of conditions, then it is very easy to represent them in the form of a decision tree and it is also easy for us to understand. If at all as the number of conditions are increasing, that means if at all we are having a nested conditions, then obviously the tree size will be increased, okay. So in that case we may not properly understand the actual requirement, okay. So for that purpose we can make use of decision tables. The decision tables help to look at every possible combination of conditions, okay. So this is the advantage of decision tables. Next, coming to the last topic, that is formal specification. So a formal specification technique is a mathematical method to accurately specify a system, verify that implementation satisfies the specification and prove the properties of the specification. So a formal specification method is nothing but a mathematical method to accurately specify a system. So in order to accurately specify a system, we will be making use of some mathematical formulas, okay. So using that mathematical formulas, we can prove that our implementation satisfy the specification, okay. That is, we can verify and prove that our implementation satisfies the specification. The mathematical techniques used include logic based, set theoretic based, next algebraic specification and finite state machines, okay. So using these mathematical techniques, we can accurately specify a system, we verify it and prove the properties of the specification, okay. Next, coming to the advantages of formal specification. Well-defined semantics and no scope for ambiguity. Since we are using a mathematical technique that is either by using finite state machines or algebraic specifications or set theoretic or logic based techniques, so there will be no scope of any ambiguity. Automated tools can check properties of specification. So if you consider this finite state machine, these are the automated machines, right? So using these automated machines, you can check the properties of the specifications, and you can have a executable specification. That means you can give assurance that whatever the properties that are required by your system, those properties will be considerably met by the product which you are going to develop. And drawbacks are, since we are using a mathematical techniques here, it is difficult to learn and use, and it not able to handle complex systems, okay. So this kind of technique can be used only by the people who are having a good mathematical background, okay. Only those people can make use of this formal specification method, okay. So coming to the summary of this video lecture. So here requirement analysis and specification is having two important phases. One is requirement gathering and analysis and the requirement specification. So an error in this phase would affect all the subsequent phases of the development. So we must be very cautious during this requirement analysis and specification. Okay. Next, the aims of the requirement analysis are: it has to gather all user requirements and it has to clearly understand all the user requirements and remove inconsistencies and incompleteness, and finally prepare a good SRS report. Okay, and the goal of requirement specification is it has to systematically organize the requirements, document the requirements in an SRS document. Okay, coming to the main components of SRS document. So in the SRS document we may have three different categories of requirements, that is functional requirements, non-functional requirements, and constraints. Those are nothing but the goals of implementation. And coming to the techniques which are used to express the complex logic, they are decision tree and decision table. Next, coming to the formal requirement specification, that is whatever the last topic we had seen just now. So it is having several advantages, but the major shortcoming is that these are hard to use. Why? Because they are using mathematical formulas or mathematical techniques. Okay, so with this we had completed the revision of unit 2 part 1, only part 1, that is requirement analysis and specification. Okay, thank you girls. In the next video let us see part 2 of unit 2. Okay.